Hello, and welcome to another Arthur Does Math video, this time for my Secondary 2 class. I don't make very many of these for you guys, so hope it works, hope it makes some sense. Please with this, if you've never seen one before, please be copying the notes that I put down here into your notebook so you can refer to them. Feel free to pause the video and rewind all that you need so that you can listen to things again or see it again if you need more clarification. And hopefully I can present the material in a way that will make sense to you. But if not, please at least write down your questions and circle things in your notebook so that I can go over them next time I see you. Today's lesson, we're going to talk about what we call special triangles. All triangles are special, but these are the extra special ones. So, special triangles. Okay, so what a special triangle is certain types of triangles follow certain rules. And if you know these rules, then it will save you a lot of work in the algebra. You can just apply the rule straight away and not have to figure it out. So I'm going to tell you the rule, I'm going to prove where the rule comes from, and then I hope that you'll be able to apply it to save yourself some time and effort. So the first type of special triangle we want to talk about is called the 45-45-90 triangle. So what these numbers refer to are the angles of the triangle. So this would be a triangle that goes something like this. Okay, so you got the 90-degree right angle, you got the 45 degrees and the 45 degrees. Okay, so right away, think about what type of triangle is this, and hopefully your first thought is a right triangle, which of course it is because that's all we've been talking about. But after that, I hope that you think about isosceles, because notice we have two angles that are the same. These are our two base angles, and despite what my picture looks like, we're going to say that, hey, we know that these two sides are the exact same. Now I'm going to do something really weird in this video. There is a purpose to it though. Although at some point during this video you're going to be asking yourself, am I really crazy or not? And yes, I am, but there's a purpose here. I'm not going to use our normal variables. I'm not going to use x, y, z, a, b, any of those. I don't want you to get attached to the letters, because when you get your assignment and test, the letters we can mix them around, and I want you to get more attached to the position on the triangle. So today, the variable of choice is going to be a star. So I'm going to call this one of the legs of this isosceles triangle. I'm going to call it star. Okay, its length is star. Star is a variable. Okay, you could replace it with 5, with 7, with -13, any number you want. You could replace it with an x or a y, but I am choosing to use star. Now, since this side is star and this is isosceles, I know that this side also has to be a star. Okay? Now, I claim that because this is a 45-45-90 triangle, there is a rule that relates excuse me, that relates the two congruent sides of this triangle to the hypotenuse. Now, I'm going to prove that rule once, and then I just want you to use it. You're never going to have to reproduce this proof again, but I feel like you should see where it comes from rather than me just throwing it out there and asking you to trust me. So, for the time being, we're going to call the long side h. Okay, that's our hypotenuse. Now, if we had numbers and stuff and we wanted to solve for h, we'd use the Pythagorean Theorem. So I'm going to do that with stars. Isn't this fun? This is more fun than numbers anyway. We need a break from numbers. Symbols are cool. So, Pythagorean Theorem says star squared, so that's one of the sides, plus the other non-hypotenuse side, so that's also star squared. I'm not liking how my stars look with this pen. It's bugging me. Anyway, is equal to h squared. Okay, so if you think about this, these are like terms. They're both stars and they're both being squared. So really what I have is 2 stars being squared. So 2 star squared equals h squared. Okay, just combining like terms there. And now I want to find what h squared is, so I need to get rid of that square root. And I can do that by doing the inverse operation of, I want to get rid of the exponent, the squared exponent, so I can use the square root to do that. So we know that these cancel. Now there's this property of square roots that we talked about in first quarter, whether you remember it or not, I promise we did, that says if I'm taking the square root of two things being multiplied, I can break them up like this. I can take the square root of the first one times the square root of the second one, which happens to be star squared. And that still equals h. And then I notice that star squared, square root of star squared simplifies and cancels out. Let's stick with green here. So what I'm left with is the square root of 2 star equals h. So the side length up here is the square root of 2 times whatever the two congruent sides are. So times star. Now I want you to remember, star is just a number here, okay? I just don't want you attached to some letters. I have to keep reassuring you because I know what you're thinking. You're thinking this is the weirdest thing I've ever done. This is crazy. Mr. Arthur, you're a lunatic. And so hang with me. Okay? But no matter what, on a 45, 45, 90 triangle, the two congruent sides are related to the hypotenuse by a factor of square root 2. So let's look at this with numbers, just so maybe you can get a better idea of what's going on here. Let's come over here. Let's do an example. This is my 45, 45, 90. So an example could be, let's flip the triangle around just so we get used to looking at it in different ways. Alright, 45 degrees. And actually, I really only need to write one of those 45s, because if I have 45 degrees and 90 degrees, the third one has to be 45 degrees. Alright, let's say, though, that this side is 7. Okay? And my goal is to find the other two sides without using Pythagorean Theorem, without doing too much work. Well, first thing that I know is, remember, this is isosceles, so this side and this side are the same, which makes this one 7. Cool. Now the third side is found by taking whatever the congruent side was, we called it star, and multiplying it by the square root of 2. Well, here the two congruent sides are both 7, and I'm going to multiply that by the square root of 2. So square root of 2 times 7. And we're actually going to leave it there. This is a no decimals section. Alright, I wish I had a sign that just said no decimals, but we're going to put it here. No decimals. Okay, so we'd leave it like that. Now, I'm going to be honest with you. Whenever we write these, you usually write the number first. Okay, so to me it looks a lot better to say 7 square root of 2. But if that just throws you off because it's different than the rule, that's fine. You can leave the square root of 2 in front. But I would prefer the number in front if you can handle that. Okay? Cool. So let's throw out one more example with this 45, 45, 90. Let's be different. Oh, that is a major fail. That is not a right angle. Okay. Fail. Let's try this again. You know it wouldn't be an Arthur lesson without bad artwork, so you knew that was coming. Alright. And 45 degrees. Okay, now let's say this time that they gave us the longest side. Let's say that they gave us 10. That's the hypotenuse. Alright? Well, one strategy that is often helpful when doing this is that you label the sides according to the rule. Our rule is stars. Okay? So I know that the longest side is equal to square root of 2 star, and I know the other two sides, which are the same, are equal to star and star. Okay, that was a lot like our rule, but you know what it also gives us? It gives us an equation that we can solve for star. Okay, I have 10 is equal to the square root of 2 times star. Well, I want to get star by itself, so let's go down here and do some scratch work. 10 equals the square root of 2 star. I'm going to divide by the square root of 2. So those cancel. And I'm left with 10 over the square root of 2 equals star. Now, I don't know if you've learned this in previous math classes. Mathematicians hate seeing this. We hate having a square root sign in the denominator. In fact, we hate it so much that we call it rationalizing the denominator when we eliminate that. But that is something that we should have learned earlier. It's no longer required for us to teach it in secondary 2. And I really just want you to focus on these triangle rules. So we're going to leave it there. If you had a previous teacher that taught you how to do it, great, go for it. But I am not going to mess with that. So my other two sides are 10 divided by the square root of 2. Okay, that's my answer for both of these. 10, oops, missed a bar, and 10 over the square root of 2. Cool, we're done. We solved for both sides. Alright, so that's the 45, 45, 90 rule. That's rule number 1, or special triangle number 1. Okay, we have another type of special triangle. Goodbye. And it is the 30, 60, 90 triangle. Okay, so again, these are referring to the angles. I'm going to draw one right here, and then I'm going to go away from it for a minute. So this is the one I'm going to keep nice and not do much on, and I'll put the rule on it in the end. And then over here, I'm going to do one that I can do some scratch work on. Alright, so this would be 60. I really ought to draw these bigger. I don't write that small. You guys can barely see that. Okay. Now, here we have to pick a starting point. Okay. I'm going to call the smaller, or the smallest side on this, I'm going to also name it star. Okay. So for a 30, 60, 90, we are calling the short side star. Again, could be x, could be 3, negative 2,562. Could be anything. Now, there's a really clever trick to prove this rule, and it's one that someone much smarter than I thought of. And once you see it, you're like, oh yeah, that works. But coming up with it, I'm impressed. So what I'm going to do is I am going to, in order to figure out the other two sides, I am going to make a mirror image of this triangle. Okay, exact same triangle going the other direction, which means that this is a 90-degree angle, this is a 60, this is a 30. Alright, now the reason that I do that is because it creates an equilateral triangle. Okay, and the way I know that is that there are 3 60-degree angles. All 3 angles are the same. So 60, 60, and then when you put the two 30s together, you also get 60. So I know it's equilateral. I also know something else. I know that this part from the middle to the left corner is also a length of star. Because that's how I made it. I told you, I made a mirror image. So it has to be. They just have to be. So the length of the whole thing, you might notice, when I put these together, is 2 star. Okay, well, that's helpful because we said earlier that this was an equilateral triangle. Well, the other property of an equilateral triangle is that all 3 sides are congruent. So if this side of the equilateral triangle is 2 star, that means that this side also has to be 2 star. Which is really helpful because that's the hypotenuse of my original triangle. No, I put an X. I've been doing so good. Hey, look at that. X's nicely transform into stars. What do you know? Okay, cool. So I have the hypotenuse now, and the shortest side. Now I just need this middle side, the other leg of this triangle. Well, it's a right triangle. I know two sides, so hopefully you're thinking Pythagorean Theorem, because that's what I'm thinking, and that's what we're going to do. So we take the short side, which is star, we square it, plus, now I know a lot of you want to put 2 star squared. Remember, that's the hypotenuse. That is the biggest side. It gets its own room. It's all the way over here by itself. Okay? And notice I put it in parentheses. I'm not just squaring the star, I'm squaring the 2 as well. So instead, we need to call this third side something. Again, I want to avoid letters. I want to avoid things that you could associate as always being part of it. So we're going to do another symbol. We're going to do a fish. Yep. That is what we are doing. We're going to call this side fish. Look at that. Like a little goldfish right there. Just you want to pop it in your mouth and enjoy it. Anyway, I'm hungry. Okay, so call that side fish. So what it goes into my Pythagorean theorem here is fish squared. So star squared plus fish squared equals 2 star squared. Now, let's solve for fish. That's what we're trying to do. Solve for fish. So I can subtract a star squared from both sides. Oh, squared, sorry. However, before I do that, sorry, jumping the gun a little bit, I actually want to square this out. I apologize. Okay. When I have an exponent applied to two things being multiplied, we have to apply the exponent to both of them. So that gives me a star squared. I need these stars to be filled in. Plus fish squared equals 4 star squared. Okay, cool. Now I can subtract the star squared. I was just so excited to subtract that star squared. I just couldn't wait. Alright. Star squared minus and minus star squared. So, those are gone. I'm left with fish squared equals, so I had 4 star squareds minus 1 star squared, so I get 3 star squareds. Alright. I'm almost there. I have almost solved the fish. Okay? I just need to take the square root of both sides. So fish side equals square root of 3 star squared. But then I'm going to apply the same property that we applied up here, where I'm going to break apart this square root. So I get that fish is equal to the square root of 3 times the square root of star squared. And then the square root of star squared is just star. So fish equals square root of 3 times star. And that star is no longer under the square root. Okay, so what does that mean? So here's the rule. Okay, hopefully you see a little bit where these are coming from. But on a 30, 60, 90, where, sorry, this is the 60-degree angle and this is the 30. Alright, so star is the short side. The hypotenuse is 2 times star, so it's twice as big. And then the third side is the square root of 3 star. Okay, and just like the rule above, this is always going to apply, no matter what, if you have a 30, 60, 90 triangle. So let's look at an example or two. I apologize, it's dragging on a little bit here. Here we go. Let's do a triangle this way. Okay. And we shall call this side 5. And the goal is to find the other two sides, if that's 60 and that's 30, and right triangle. Okay, again, I strongly recommend, let's label these sides. The short side is just star. The longest side, or the hypotenuse, is 2 star. And then the third side is square root of 3 star. Alright, well, notice that since I labeled these, that means that star is equal to 5. So everywhere there's a star, I'm just going to replace it with 5. Okay, so I know that 2 times star is the same as 2 times 5, which just equals 10. Okay, so one of my answers is 10 for the hypotenuse. And then this one here is the square root of 3 times 5, which is, I don't want decimals again, so about all I can do to clean that up is just make that 5 square roots of 3. And there's my other side. Okay, pretty simple if you know the rule. So this is something you're going to want to write on a test note sheet and try and commit to memory as much as possible. But until then, I suggest that you do a bunch of labeling as we go. So, 2 more quick examples, and then we're done. Let's see if we can do this. I want to keep that rule visible, but I'm not doing a very good job of it. Right there. Alright, let's do another example. I think I can squeeze it in here. Okay, this time I'm going to do kind of a weird one, okay, because it is on your homework, and I want you to be prepared for it. Oh, not even close to straight. Alright, 60, 30. This time, let's say that they gave us the hypotenuse, okay? And we'll say that the hypotenuse is 4 times the square root of 11. Alright, kind of messy, but we can handle it. So let's go through and label our sides. Remember, shortest side, that is star. Longest side is 2 star, and since we know what that is, we can say equals. That's going to be helpful in a minute. And then the third side is square root of 3 star. Alright, so let's get to work. Over here I have an equation that I can solve for star. I'm going to come off to the side here. 2 star is equal to 4 square roots of 11. So if I divide both sides by 2, I get star by itself. And when we have this situation, we're just going to divide the whole number parts. So 4 divided by 2 is 2, so I get 2 square roots of 11. Cool, that's one of my sides. Alright, that's star. 2 square roots of 11. And then the last piece is to take whatever star is and multiply it by the square root of 3 to get that third side. So, let's do that. We'll go in red. So I'm going to do the square root of 3 times the whole thing, 2 times the square root of 11. Alright, I just plugged in star. Remember, square root 3 times the star value. That's the star value. Alright, just need to clean it up a little. Another property we talked about in first quarter with square roots is that when you are multiplying square roots together, you can multiply their radicands, which is the parts under the radical symbol. So I can multiply 3 times 11, and I can get that third side to be 2 square root of 33. Again, no decimals, so that's just how I'm going to have to leave it. So my third side is 2 times the square root of 33. Perfect. There's one of my answers that I needed. There's the other one. Alright, so please don't be scared of the square roots, and please don't just turn to your calculator right away. You can handle these, I promise. Okay. Last example. I gotta move that rule. I don't know how to keep it there unless... Wait. There. Off to the side. Okay. Last example. Let's say they give you the middle side. Okay. We'll go back to this way. 30, 60. And let's say that they made this middle length side 8. Okay? Same approach. Write what each side is. Alright, I know the short side, that is star. I know the hypotenuse, or the longest side, that's 2 star. And then the third side I know is equal to the square root of 3 times star. Okay, so then I'm going to focus in on the one equation that I do know, that 8 is equal to the square root of 3 star. Let's come down here. Okay, and then just to get star by itself, I'm going to divide by square root 3. So those are gone. And I'm left with 8 over the square root of 3 is equal to star. Perfect. That's my short side. 8 over the square root of 3. Okay, now that I have star, to get the third side I just need to multiply it by 2. So let's come over here and let's do 2. So let's do this. 2 star, just so you know what we're doing, is equal to 2 times 8 over the square root of 3. Well, remember, when multiplying fractions we go straight across, and I can make this 2 into a fraction by just putting it over 1. Can always do that. And then I'm going to multiply straight across. So I get 16 over the square root of 3. And we're just going to leave it that way. Okay? Bugs me a little bit, but it's not worth the fight right now. So 16 over the square root of 3. Bam. There's one answer. 2 answers. Sweet. Oops. Okay, so quick recap. First thing, please make sure when you're looking at this assignment that you check to see what type of triangle you're looking at. So the 45, 45, 90 has this rule right here. 2 congruent sides, and the third side, which is the hypotenuse, is equal to the square root of 2 times the length of one of the other sides. Alright, so we can solve things there. Then if you have a 30, 60, 90 triangle, and again, they may only put the 30 or the 60 on the triangle, but the other one is implied because it has to be there. This one has a little bit more unique relationship in that the short side, which, I'm sorry, this camera makes it look like the sides are the same, but on my paper, it's not nearly as skewed. Hopefully the other ones make it clear. But the short side is always our single unit one, so we'll call it star. The hypotenuse, or the longest side, is 2 times star. And then the third side, the middle length side, is the square root of 3 times star. And I have given you an example of every type of problem they could throw at you. Okay, I've given you all starting from all different sides. So if you get stuck on something, you might want to come back to that certain part and look it over. Please try on these. Okay, don't be scared of the square roots. You can do it, I promise. So it is a short assignment. It is like 10 questions long, and I bet you can finish it in class. So thanks for watching. Please bring your questions to class next time, and I'll see you then. Bye.